Right now, the sun is exactly where you think it is. You can't see it through your ceiling, but you trust it's there. You've never once doubted it. But somewhere in the next 48 hours, that trust is about to be tested because the sun is going to go dark, and your body has no idea what to do about it. This isn't an eclipse. An eclipse passes in minutes. This is 2 full days, 2 sunrises that never happen, 2 sunsets that already happened and never repeat. And the strangest part isn't the darkness itself. It's what happens inside you before you even notice the dark. Light from the sun takes about 8 minutes to reach Earth. So when the sun goes out, you don't go dark instantly. You get 8 minutes of completely ordinary daylight first, a strange, false calm before the actual event arrives. It means the last thing anyone on the daylight side of the planet sees is a perfectly normal sky, seconds before it stops being one. Then it happens. Not a sunset, not a fade, a switch. Within seconds, the sky doesn't dim. It disappears. Stars that were invisible all afternoon suddenly blaze into view because without sunlight scattering through the atmosphere, there's nothing left to drown them out. For the first time in your life, you might see the Milky Way at 2 in the afternoon. Your eyes adjust fast. Your mind doesn't. Inside your brain, a tiny cluster of cells called the suprachiasmatic nucleus has spent your entire life tracking sunlight to keep your internal clock on schedule. Harvard sleep researcher Charles Czeisler has spent decades studying this clock, and his research shows it doesn't run on hours or minutes. It runs on light. Take the light away, and the clock doesn't stop. It drifts. Within the first day, your body starts releasing melatonin at the wrong times, confusing day for night and night for something it has no name for. You'd feel exhausted at 10 in the morning, wide awake at 3 in the morning, hungry when your stomach has no idea what meal it should be expecting. Why does losing one external cue unravel something so deep inside you? Because that cue was never just lighting. Sleep scientist Stephen Lockley, who has worked alongside Czeisler studying astronauts and night shift workers, has shown that light is the single strongest signal your body uses to decide what time it thinks it is. Stronger than a clock on the wall, stronger than a schedule on your phone. Take it away completely, and your biology starts guessing. And you wouldn't be the only one guessing. Birds that navigate by the position of the sun would lose their bearings within hours. Bees, who time their entire foraging schedule around daylight, would stop leaving the hive altogether. Oxford neuroscientist Russell Foster, who discovered the light-sensitive cells in the eye that anchor this whole system, found that almost every living thing on Earth carries some version of the same internal sun-tracking clock. Take the sun away, and you're not just confusing people, you're confusing the planet. But here's where the real damage begins. And it's not in the sky, it's in the ground. Plants don't stop working the moment the lights go out. They're smarter than that. Most plants store a reserve of starch built up during daylight hours, enough to survive a single dark night the way they always have. But a 48-hour blackout is a night and a half longer than anything their biology was built for. Crops begin pulling on reserves they were never designed to spend twice. Leaves that were green at hour 1 start yellowing by hour 30. Phytoplankton, the microscopic organisms that produce roughly half the oxygen on Earth, stop photosynthesizing entirely. They don't die in 48 hours, but the ocean's oxygen production, quietly powering nearly every breath you take, goes completely silent for 2 full days. You wouldn't notice that part? Not yet. The atmosphere holds enough stored oxygen that 2 days of silence wouldn't touch you directly. But it's the first sign that something much bigger than darkness is happening. The planet's life support system, the one running in the background of literally everything you've ever done, has just been switched off. Meanwhile, the temperature is already falling. Without the sun's heat reaching the surface, Earth begins losing warmth into space faster than it can hold on to it. Climate models built around sudden solar loss suggest surface temperatures could drop somewhere in the range of 10 to 20 degrees Celsius within the first 24 hours alone, colder in regions already losing daylight, slower in places insulated by cloud cover or ocean currents. By hour 48, large parts of the world could be sitting at temperatures that belong to midwinter, regardless of what season it actually is. Frost would appear in places that haven't seen it in years. Rivers in cooler climates could begin icing at the edges. Farmers checking on crops they planted that same week would watch the soil temperature fall in real time, hour by hour, on a screen that was never built to show numbers like that. So why hasn't civilization collapsed by now? Because 2 days, it turns out, is short enough to survive. Just barely. Power grids keep running, since most of the world's electricity has nothing to do with sunlight directly. Solar farms, though, would go completely dark, forcing every grid that depends on them to lean harder on backup sources within hours. Hospitals run on generators. Cities run on stored fuel. The infrastructure humans built turns out to be remarkably resilient to 2 days without a sun, which is the opposite of what most people would guess sitting in the dark for the first time. What actually breaks first isn't the power. It's the people. Researchers studying crews who spend months in continuous darkness at Antarctic research stations have repeatedly found that mood, focus, and decision-making begin deteriorating within the first 1 to 2 days of disrupted light exposure. Anxiety rises, sleep fractures, small decisions start to feel enormous. And that's in people who knew the darkness was coming, who trained for it, who had routines built specifically to survive it. Now imagine it happening to 8 billion people who didn't see it coming. Panic buying empties stores within hours. Streetlights become the only light source in cities that forgot what true darkness looks like. Children born after their region's last major blackout experience, something they have never witnessed in their life. A sky their grandparents would recognize on sight and they wouldn't recognize at all. And then, at hour 48, exactly on schedule, the sun comes back. Not gradually, not with a sunrise, just light, returning the same way it left, instantly, completely. 8 minutes after whatever switched it off, switches it back on. The frost begins melting within hours. Phytoplankton resume photosynthesizing, as if they'd simply paused mid-sentence. Crops that survive the cold snap recover slowly over the following weeks, though some, pushed past their threshold, wouldn't make it back. Birds find their bearings again almost immediately, as if the confusion had never happened at all. You, on the other hand, take longer. Cheisler and Lockley's research on circadian disruption suggests your internal clock wouldn't simply snap back the moment light returns. It would take days, sometimes longer, for melatonin cycles, hunger, and alertness to fully resynchronize. The same lag experienced by long-haul pilots and shift workers whose bodies never quite agree with the clock on the wall, even years into the job. Which means the most lasting damage from 48 hours of darkness wouldn't be the cold or the panic, or even the stalled oxygen production quietly humming back to life in the ocean. It would be the slow, days-long confusion sitting inside your own body, proof that the thing keeping you on schedule every single day of your life was never really a clock at all. It was always the sun. And maybe that's the part worth sitting with the next time you complain about jet lag, or a bad night's sleep, or feeling strangely off after the clocks change by a single hour. Your body isn't being dramatic. It's running the same ancient program it always has, the one built entirely around a light source 93 million miles away that you've never once had to think about. Right now, the sun is exactly where you think it is. This time, maybe that's worth noticing.